Hey guys, I hope you had a great weekend. We have one more week and then spring break. Yay. So today we're going to cover Unit 8, Lesson 4, but I want to cover a few things before I get started. So this week we're going to do Lesson 4 today. I'm going to go through the notes. You watch the video, do your notes, and then there's an activity that you're going to do. And then tomorrow we're going to do some task cards. So it's going to be posted in Canvas. You'll work on that. I will post a video again tomorrow going over a couple of those problems. And then Wednesday, we're going to do review. It will be either a Kahoot or a Quizzes, something you can click on and play. And then Thursday, we will take a test. Okay, so the test will cover everything on this list right here. The characteristics of quadratic function, which was all the stuff we did in the project. Quadratic regression was part of that. You're not going to see that on the test. It'll cover domain and range, which was the lesson from last Wednesday. And it will cover the stuff from today that we're going to practice today and tomorrow, which is applications of quadratics. So word problems, real world situations for quadratics, okay? So if you have any questions, if you're confused about anything we've done, then make sure you email me. The project that we were working on, we spent 7 days. You guys had 7 days, 7 class days, and a whole weekend in the middle to work on that. It was due on Friday. If you did not turn it in on Friday, it is now late. You will get nothing more than an 80 on it. If you turn it in tomorrow, which is Tuesday, you will get nothing more than a 70 on it. If you turn it in on Wednesday, you will get nothing more than a 50, and then after that, it's a 0. So get it done. We had 7 full class days. I was posting updates every couple days during class. I had posted a video showing you guys what to do. I did an entire problem with you. So make sure you got it done. Turn it in, okay? I'm making this video on Friday, and at this point, I only have 2 turned in. So y'all need to get busy, get that stuff taken care of, okay? It is a test grade. That's your first test grade for the next 9 weeks. Okay, the 9 weeks. The 9 weeks ends on Friday. So Thursday we'll test. Friday, you will be able to do test corrections and get any work turned in. Friday, I will not accept the project. The project has to be turned in by Wednesday. I'm not going to accept it after that. It's going to be a 0, okay? So Friday, you can work on any other daily grades that you're missing. You can work on test corrections for the test we're taking Thursday. I'll try to have those posted for you, or you need to email me if you want to do test corrections. I'll have the grades in before I leave Thursday afternoon. So it'll be a work day, catch-up day, okay? So if you have any questions, then let me know. All right, let's get started. We have Unit 8. Let me put a pencil on. Here we go. Unit 8, Lesson 4, and this is going to be applications of quadratics. And we're going to scroll down. So on the notes that you have, we were going to do transformations for Lesson 4. This is actually going to be Lesson 5, and we're going to do it after spring break. We're just going to move that to our next unit because we wanted to be able to get this test in before spring break, so that way you don't have to remember everything over the break, okay? We do need to remember you have a STAR test, but anyway. Benchmarks. We will take benchmark on March 31st. You guys need to plan on being there, being here at campus. You need to be here by 7:40 so that you can get to your classroom that you're supposed to be in. So you'll come in, you'll take your test. When testing is released, you'll be able to go home. So March 31st, we will be doing Algebra 1 benchmarks. So plan on being here. Make arrangements so you can be here. Make arrangements so you can get picked up, whatever you need to do, okay? March 31st is Algebra 1 benchmark. Hopefully I'll get to see you guys. If you guys see me, then say hi. Make sure you tell me who you are so I can actually meet you in person. All right, so this is actually going to be Lesson 4 and quadratic equation word problems. So let's read. Your friend, I'm going to read from my iPad because it's a little bit easier for me. Your friend can eat a lot. Cheeseburgers are his favorite, so he gets happy when he eats them until he has too many. If you measured his happiness, h of x, so that's just the name we're giving the equation, based on how many cheeseburgers he eats, x, so x is going to be the number of cheeseburgers, you'd get a curve that looked like this. H of x equals negative x squared plus 6x plus 16. So graph h of x. Don't forget to label your axes. So first, let's label our axes. We know that the one that goes side to side is x, and the one that goes up and down is y. Or we could also say this is h of x. That's okay too. H of x and y are the same thing. And then I'm going to go to Desmos, and I want to show you guys how to do something in Desmos. So let me see if I can get these screens side by side here. We'll leave that there for now. Okay, so in Desmos, I'm going to type in the equation. H of x equals negative x squared plus 6x plus 16. And it gives me this graph. I'm going to zoom out a little bit. Here we go. Okay, so I want to graph this. I want to put this line on this paper. But this is kind of hard to see. Like, I can see the vertex. That's pretty easy to see. I can see the x-intercept, and I can see the y-intercept. And so I can use these 3 points to graph it on this line. I also want to show this to you really quick. I'm going to use these 3 points. I'm going to show you how to use these 3 points. But I want to show you how you can come up with more points. So you can do this little settings button, the edit list, and you can click table, and then it will give you a lot more points. It'll give you more points, okay? So you can just you can click here and go in. Whoops, maybe not this one. Enter. If you just keep clicking enter, it'll keep adding points. So now you have multiple points here that you could graph on this line to be able to make it more accurate, okay? You can use this on the STAR test. Desmos, you will be able to use Desmos on your STAR test. So I wanted to point this out and keep this in mind, okay? So let me make this a little bit bigger. Make this a little bit bigger. Here we go. All right, so I'm going to use the x-intercept, the vertex. I'm sorry, this is the y-intercept, the vertex, and this x-intercept. So this graph, there's my y-axis. So we're only plotting the positive part of my x's, okay? So I'm going to come over here. I'm going to say, well, I have x's and y's. I'm going to use 0, 16, 3, 25, and 8, 0. Okay, so that means on my x-axis, I need my x's to go all the way up to at least 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And we could keep going, but I don't need any more than 8. So I know that I'm going to have 1 point right here. Let me change colors for my points. I'm going to have 1 point right here at 0, 8. At 8, 0. So there's my first point. I need my biggest y value, or my h of x value, has to be 25. I don't think I have 25 lines there. I think I only have like 15 maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's only 15. So I need to be able to put that point 325 on my graph. So I think I'm going to count up by 2s, because if I have 15 lines, if I multiply each one by 2, then that will give me 30. I'd be able to go all the way up to 30. So I'm going to go up by 2s. I'm going to do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. So now I have somewhere in those gaps I can get 25, and I have a line that has 16 on it. So now let's plot these points. I have this point 0, 16. That means I'm on the y-axis, and I'm going to have a point at 16. Okay, and then we have a point. Let me change to a different color. 3, 25. So I'm going to go over 1, 2, 3. And I'm going to go up 25. So up here, let's see, here's 24. So 25 is going to be just a little bit in between 24 and 26, right? Halfway in between there. And I can connect my points. And wow, that looks really bad. Hold on, let me try that again. I'm not very good at doing this. Oh, that looks bad too. Hold on. That's better. We're going to stick with it, okay? My lines are not perfect. I don't claim to be an artist. Okay, so here we go. We've graphed our parabola. The next question, if your friend wants to be as happy as possible, how many cheeseburgers should he eat? How do you know? Okay, so what's happening here is on the bottom, this is the number of cheeseburgers he's eating on my x-axis. And then on the, right? Yeah. On the y-axis is his level of happiness, okay, from 0 to 30. His level of happiness. So what's happening is he's eating cheeseburgers. So this, as we're going along this line, he eats 1 cheeseburger, it makes him a little bit happy. He eats 2 cheeseburgers, he's a little bit more happy. He eats 3, he's happy, he's a little bit happier. And then he gets to 4. Let's see. Oh, I put that on the wrong line. No wonder my line was not working. Hold on, guys. 1, 2, 3, up to 25, right here. That should be a purple dot. That's what I highlighted it. Purple. I graphed it wrong. Here we go. Okay. So he eats 1, he's a little bit happier. 2, he's a little bit more happy. 3, he's a little bit happier. And then at 4, it's coming back down. So he's not so happy anymore. And then 5, it goes down a little bit more. And 6, it goes down a little bit more. And 7 and 8, he's down. He's not happy at all. Okay. So why? Why is that the case? Well, I mean, if you eat 1 hamburger, you're feeling good. You're like, yeah, I'm full. Okay, I'm getting, my stomach's good. You eat 2 hamburgers, you're like, okay, yeah, okay, I'm getting a little bit more full. Okay. And then 3 hamburgers, you're like, okay, I'm full. I'm like, I'm not hungry. I'm good. When you eat 4 hamburgers, you're like, okay, I'm going to throw up. I don't feel good anymore. It's bad. 6 and 7 and 8, like, no, I can't do it. I'm done. Right? I'm down for the count. So that's what's happening. His happiness is going up, but then at a certain point, he's going to eat too many hamburgers and his happiness is going to come back down again. So on number 2, it says, how many cheeseburgers should he, I've been saying hamburgers, how many cheeseburgers should he eat to be as happy as possible? So as happy as possible means the highest, that vertex. So the happiest, he has had 3 cheeseburgers. Oops, spell it right. And then how do you know? Well, after that, it starts going down. Say that's the highest of the parabola. That's the highest point of the parabola or the vertex. Let's say that. Let's use our vocabulary. That is the vertex. Okay. So number 3, what does the y-intercept of this graph represent? Okay, so the y-intercept is right here. So he's had 0 hamburgers at that point, and his happiness is at 16. So he is starting at a happiness of 16. That's what that means. And then number 4, how many cheeseburgers can your friend eat before he becomes unhappy? So when does he start becoming unhappy? Well, at 3, he's happy, and then 4, say on the 4th cheeseburger. He doesn't even have to eat the whole 4th cheeseburger. If he takes 1 bite of that 4th cheeseburger, he's not happy anymore. His stomach is starting to hurt, okay? Calculate your friend's level of happiness if he ate 10 cheeseburgers. So what does that mean? So this is another thing I'm going to use Desmos for. So I don't know if you guys remember doing function notation, but since this is written as h of x, you can come over here and say, well, at h of 10, he is at negative 24. That means he has no happiness. He's like, he can't even fathom being happy. Like he's done, he's out. He's not going to be happy for a while. Okay. So this means he has negative happiness. He's not going to be happy for a while. Okay, I'm going to do this problem also. You can skip ahead. Like if you kind of get the idea, you can go ahead and start working on the activity. But I think some of my guys that are online, y'all might like this problem. This is kind of, more applicable to you guys. So in football, some of the most important plays happen in the final seconds of the game. If a team needs to score, sometimes they throw a Hail Mary, a long pass that goes almost the whole length of the field. If the team catches it, they score. If they don't, they lose. The University of Washington Huskies tried throwing one of the longest Hail Marys in history, about 73 yards, which is ridiculous, okay? For this pass, the ball's height over time was modeled by the function h of t equals negative 16x squared plus 64x plus 6, where h of t was the height. So h of t is telling me how high the ball's going. And t was the time in seconds. So this is telling me how high the ball is going, the height of the ball. And as I'm going this way, it's telling me how long it's taking the ball to get back down to the ground, okay? Let's break down whether the Huskies ever had a chance, okay? So if 73 yards isn't just a long way to throw, it's a long way to run. To give his team the best chance of running all the way down the field and catching the ball before it hits the ground, the quarterback needs to keep the football in the air for a really long time. How long was the ball in the air? So I'm going to come to Desmos. I'm going to write this as h of t equals negative 16t squared. I'm just writing the equation they gave us, plus 64t plus 6. Okay. So this means he threw the ball. So he started throwing the ball at 0 seconds, and it's 6 feet in the air. That means when he's standing up, he's probably taller than 6 foot, right? Because you usually throw the football from like this right here, not above your head, right? You don't throw it up from up here. Maybe they do. Oh, I guess so. Maybe like if they're talking about the time it actually left his hand, it would be higher than him. Maybe he's not 6 foot. Okay, so anyway, he's throwing the ball. So it starts at 6 foot. And then it goes up and 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 up. And then it starts coming back down. It's coming down and down, 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 down. And the question says, how long was the ball in the air? So this part this way represents the number of seconds that have passed, okay? So the ball leaves his hand at the y-intercept. That's where it starts going in the air. Then it goes all the way up and comes back down and hits the ground. So this is where it's at 0 feet. It hits the ground, and it's been 4 seconds. So it's been we'll go ahead and write this. We can say 4.092 seconds. We can say about 4 seconds, right? I'm going to round that a little bit. It takes a good college football player about 8 seconds to run 73 yards. How long should the quarterback have waited before he threw the ball? So it took 4 seconds for the ball to get all the way there and hit the ground. But it takes the player 8 seconds to run 73 yards. So they were throwing it 73 yards, and it took him 4 seconds to get the ball there. So how much longer should he have waited? He probably should have waited another 4 seconds before he threw the ball. Right? Because 4 plus 4 would be 8. I'm sorry, I got this over here. Y'all can't see. After the quarterback threw the ball, the cameras lose sight of it. It went so high that it was out of sight. If the camera can only see 40 feet high, how long was the ball out of sight? Okay, so literally what my screen is showing right now. Look, there's 40 feet. So all the stuff above here, above 40, is the time it was out of the camera's view. So let's see, it went out of view at like 0.63 right here, and then it came back in view at 40 feet around 3.37. So let's say like this is almost a half a second, right? More than half a second. And this is, what's that difference? Like 2.6 6, 7, 8. Let's write it down. Let's do 3.4 minus 0.6. Let's do that. So we'll round it. 3.4 minus 0.6. So what are we left with? We have 3 to carry the 4, 6 to 14, 7, 8, and then 2. So 2.8 seconds. So the ball was out of view for 2.8 seconds. Okay, how high did the ball go? So here's the highest it went, and that's right at 70 feet. So even when the pass is accurate, the ball goes far enough and the team has time to catch it, Hail Marys don't usually work. If you need to know whether it worked for the Huskies, there's your answer. So there's a bit.ly you can type in online and watch the play itself, okay? All right, so there's the notes for this this unit. Now you need to do applications of quadratics practice. Use Desmos. Type your equation in Desmos. Identify what's happening. The x-intercept's where it starts. The vertex is the highest it's going to go. Anything's going to happen. The most amount of time, the most amount of money, whatever. And then the x-intercept is where it's hitting the ground or where it's over, where it's stopped, okay? And we only care about that region. We don't care about anything in the negatives. We don't care anything about the negatives this way, okay? Just that region there. All right, if you have any questions, let me know. Remember, we're reviewing on Wednesday. Take a test on Thursday, all right? See you later.